So, we humans have altered a lot of biogeochemical cycles. The one I actually hear talked about most is the carbon cycle, which we will get into when we talk about global climate change. Um, but the nitrogen cycle is a huge one. Um, just looking up some numbers today to report to you all, and found that natural nitrogen fixation, which is primarily biological, conducted by bacteria in the water, in the soil free, or in the soil associated with plants symbiotically. Um, that's somewhere between 100 and 300 teragrams per year. Big range because it is an estimate. And a small fraction of natural nitrogen fixation, somewhere like in the 10 teragram range, is actually from lightning. The electrical energy released by lightning can split nitrogen gas apart, and it will reform with hydrogen into ammonia or another form of biologically available nitrogen and precipitate down in rain. On the human side, we have a better grasp on that. That's like 180 teragrams per year, so we could say roughly equivalent to the amount that's fixed naturally, uh, which is nuts to me that we're matching the natural nitrogen fixation, more or less. The vast majority of that is done by the Haber-Bosch process, which takes heat and pressure and a catalyst and splits that atmospheric nitrogen gas apart and turns it into a biologically available ammonia, something we can offer to our crop plants. This will be a short video, but I just wanted to show you a whole bunch of natural nitrogen fixation happening. These are all alder trees, just like John mentioned in his lecture. And if you dig at the base of an alder tree and dig up some roots, some trees have more of that symbiotic association than others. But what you're looking for that symbiosis in the genus Ulmus and the family Fabaceae, which is pea-related plants, legumes, you're looking for these little root nodules like this. And that is a structure that the plant builds to house those symbiotic bacteria. And just like John said, this alder tree right here is offering the bacteria photosynthate, so sugars produced by carbon fixation and sunshine energy. And in exchange, those bacteria, and it's offering them a home. And in exchange, the bacteria make nitrogen, which is one of the major limiting nutrients in most ecosystems. Pretty good trade, and you find these big stands of alder inhabiting kind of newly disturbed sites where there aren't a lot of nutrients available. Same with legume plants. A lot of plants in Fabaceae inhabit newly disturbed areas, and they can come in often with just like bare mineral soil and make it work. Thanks, bacteria. Thanks, symbiosis. And another thank you. I ate a whole bunch of food a couple of times today, and I guess I got to thank the Haber-Bosch process, because that was certainly used to fix the nitrogen that was used to grow the plants, that was used to make the food that I ate. There you go, biology in action.